Okay, and our third type of question, again, 5 amazing marks to be had here. Don't be scared because it looks quite, tricky, but it really isn't. Okay, so electricity in a spacecraft can be produced by a type of nuclear generator. The electrical power produced is modeled by this function. So P is my power, and T is the time. So determine the power initially. Now, for this, let's just have a very quick think about what our function is. So an exponential function, I'll draw it on this side. An exponential function does something like this usually. Okay, so that could be y is equal to 2 to the x, 3 to the x, whatever. Okay, so this is a function that is doubling with time, 2 times 2 times 2 times 2, etc., etc. So they get very big very, very quickly. We have got, pardon me, a base E, Euler's number. Now that shouldn't confuse you. It is just a number. It's a magic number that pops up in quite a lot of mathematical models. Okay, but it's still just a number. Okay, 2.7. So that's still effectively imagine its base, 3, 2.5, whatever. It is still an exponential growth. So that's all we've got. Now, instead of just having an x up here, I've got a number next to it. Now this number next to it will control the steepness of the graph, and it controls which way round it is. So just for your own information, that negative will be making it do this. When you see a negative, you're looking at a decay. Okay, so it's going down and down and down, and it will never quite reach, the bottom. Okay, and that goes through at 0, 1. Okay. So if I've got 120, this is just say y is equal to e to the x. If I've got 120 at this point here, I've got 0, 1. If I times this function by 120, it's going to go up, multiplied by 120, isn't it? Come through here. So the first thing to note is that this number is always going to give you your initial power produced. And you could check that by saying, okay, well, what if I'm looking at the power initially produced? So initially, 0.0079 t is 0, because time is the starting point. That is going to come out as 0. So you're going to end up with 120 e to the 0, and end of our 0 is 1. So you've got 120 multiplied by 1, so it's just 120. Okay? So first thing with these is this number, is always your initial, starting point. So for 1 mark, they just want you to say 120. You could prove it. Okay? And again, I'm just trying to give you a bit of information. This is a negative. We've got a decaying function. If it's positive, we've got an exponentially growing function. So decay, maybe the power is not producing as much as time goes on, whereas an exponential growth might be something like bacteria, or like the COVID virus, going up and up and up. The next one is saying calculate how long it takes for the power produced by a generator to reduce by 15%. Okay, so how long? So 120 e to the negative 0.0079 t. I'm trying to find t, and I want to know when it's producing 15% less. Okay, well, there's 2 parts to this. 120 is my starting point. So how can I work out 15% less? I'll just do it by hand, just for fun. Okay, 10% divided by 10, so 5% would be divided by 2. So that'll be 6. So 15% is going to be 18. Okay, so that means 120, where I started, if I take off 15%, I'm taking off 18. So that's going to be 102. So sometimes it's quite nice. It maybe says half, so half that number, double that number, whatever. Okay, but they've made you do a wee bit of, percentage work for this. But that's the power that I'm looking for. That's the power I started with, and this is my function. I'm going to find time. So the first thing you can do is divide by 120. That's allowed, isn't it? It's going to divide by 120, just like normal. Yep. So 120, 102 divided by 120. It's going to give me e to the negative 0.0079 t. And this is where logs are really good. So to try and get this away, try and get this down off the e, if you think of it like that, I'm going to take natural logs of both sides, which is ln. And again, we don't really talk about that. On your calculator, you'll notice you've got a log with the squares that you can choose what you want to do. So you can do any base you like. you're going to have ln, which is your natural log, which is a log to the base e, and you just see the log button, which is actually log to the base 10, because that comes up quite a lot. So be careful when you're doing them. You don't confuse the buttons. Yeah, you get different buttons. We're going to go with the natural log. Okay, so I'm going to take logs of both sides. So I'll take log of this, and I'm going to take a log of this side. So a natural log of E0079t. Okay. And what happens here with the beauty of logs is that they cancel out. If I've got log base e to the power e, that effectively cancels out, and I'm left with the natural log of this equal to negative 0.0079t. Fantastic. And again, just to get rid of this number, I'm just doing dividing the way we've done since the very beginning, so 102, 20, and I'm going to divide that by negative 0.0079, and that is going to leave me with t. So right now, just practice that on your calculator. Make sure you can type that in, okay? I have very foolishly left my calculator at school, so I've got my phone, which I wouldn't recommend doing because you want to get used to using your calculator. And 20.572 years is the answer for that one. So look, again, 5 marks. This is always our starting point. So the 1 mark, that's an easy one. And for this bit, all you're having to do is put in your new power and then rearrange. Yeah. So dividing by this term. The hard thing is known to take natural logs of both sides to cancel out this e value. Okay, that's the tricky bit. But again, when you actually look at it, quite a straightforward move, really. Okay? And then again, take this and divide. The numbers are quite big. The terminology is more advanced than maybe what we're used to. But in effect, it's the kind of rearrange you've been doing from first year, which maybe y is equal to 2x squared plus 2 divided by 3 or something. It's know the order and knowing what to do. The numbers are just a bit more wild. Okay. So I hope that's helpful. The next video I'll rush through a wee bit faster. I just want to take a wee bit of time to chat about that. So the next ones we'll go through them and we'll go through without chatting too much. Okay. So I hope that's helpful.